Hello, let me present my paper about an FPGA-based RNN-T Inference Accelerator with PIM-HBM. First of all, Hbm Pm should be explained. Hbm Pm is the first processing in memory engineering sample using the commercial DRAM 20nm process, which was announced in ISCA 2021. Hbm Pm is able to boost DRAM bandwidth more than 4 times using bank level parallelism. By using the protocol used in the commercial HBM2 device, it is fully compatible with the JEDEC standard, which enables drop-in replacing on HBM2 integrated SIP. Let's look at the structure of HBM Pm briefly. Based on 8 high product, there's a buffer die which is directly connected with the host chip via silicon interposer. Then 4 PIM DRAM dies are stacked on the buffer die, and then 4 additional DRAM dies with a PIM are placed on top of them. As shown in the central figure, HBM units are placed between 2 banks, and PIM units can operate in parallel accessing each local banks. Next, I will explain the application that I want to accelerate in this paper, named RNN transducer. This is known as Google's LSTM-based voice recognition model and is kind of a state-of-the-art of the speech recognition. It is also included in MLPerf benchmark, which is commonly used for new hardware and software evaluation. Once we provide the application in GPU system, we found out that LSTM layer takes more than 90% of the execution time. You can find the equation sequences of LSTM cell at the figure on the right, and the part up in the red dashed box is computed as a vector matrix multiplication, which takes most of the LSTM execution time. LSTM cells generate new hidden value based on the old hidden value, so it has to be executed sequentially. Usually the amount of the weight used in the cell is greater than the size of the on-chip SRAM. The data is not reusable across multiple time steps. Hence, we can conclude that RNN-T is memory bound and a very suitable target for PIM. Now we are going to introduce the RNN-T accelerator that we've implemented. For fair comparison, we have separately implemented 2 versions, the PIM version and the non-PIM version respectively. Both versions share most of the logics to execute the RNN-T application except for vector matrix multiplications. The PIM version lets vector matrix multiplication to be executed using multipliers and adder tree using FPGA logic. On the other hand, the PIM version approaches vector matrix multiplication to HBM PIM. The PIM initiator is a kind of a host-side PIM controller. It mainly has 2 roles. First, it automatically generates PIM instructions based on given operation type and input and output dimensions. Second, the PIM initiator generates in-order memory access to HBM PIM via AXI bus. In addition, we implemented various nonlinear functions such as sigmoid and tanh by using a lookup table-based approximation. The experimental environment is as follows. 2 Xilinx Alveo U280 boards are installed in Intel Xeon Platinum CPU server. One is with HBM PIM and the other board is without PIM. CPU delivers data and signals to FPGA through PCIe press interface, runs the entire model via start signal and waits for the done signal. Okay, let's look at the power numbers. PIM FPGA uses 4.9 watts less power in logic, 0.6 watts more in HBM due to the PIM function. Okay, let's move on to the experimental results. PIM FPGA performs 2.5 times faster than non-PIM FPGA. We observed that both implementations use more than 80% of peak bandwidth continuously, confirming that both versions are implemented efficiently for memory-bounded RNN-T applications. Given the fact that our PIM accelerator uses 425 times smaller DRAM bandwidth than NVIDIA A100. Our PIM accelerator is only 30 times slower than the world's best implementation based on A100. Considering this, once we estimate the projected performance under the assumption that our accelerator can use the same level of bandwidth, PIM FPGA becomes 1.98 times faster than that of A100-based. In addition, we checked the accuracy drop caused by using the FP16 operator and nonlinear function approximations. PIM shows 8.09 WER, satisfying the MLPerf performance qualification criteria.